And we know this is Kansas, right, where the wind never blows. So yeah.
Another one about Nebraska sucks and Oklahoma blows.
We used to say Wyoming blows. Yeah. Okay. Anything else? Sorry, I'm kind of squinting up here, but that is a really bright light. I feel like I'm kind of being interrogated or something, you know. Yeah. I do this a lot, you know, teach in rooms with projectors, but they rarely ever point directly. Well, that's probably good. Okay, so let me go ahead and start the show here. First of all, just a couple of things that are kind of by way of information, and I think we've already talked about this already, but obviously you know about the general meeting since you're here. The next public night is Saturday night, and we have it down at 8 p.m. Is that still still about right? I mean, it's obviously dependent on sunset and darkness and all that sort of thing. Next general meeting is a little later in the month, in October. It's October 28th. So and I think we'll be doing that meeting also as a hybrid meeting. So as we did this time, we will actually ask people to RSVP if you want to attend in person, because we do have to kind of control the number of people that actually come in person. I don't know what the rated capacity of this room is, but we might want to make sure that some of you stay slightly out of sight right now, because we might be a little over. Yeah, yeah. And then the November general meeting, 18th, is that correct? We always
we do it a week in November because of Thanksgiving.
Because of Thanksgiving. Okay, so these are kind of the upcoming meetings. Anything we want to add to this?
There'll be some public meetings.
Okay.
And maybe members night.
Okay.
Yeah.
One thing is that the public night on the 25th, I believe that's our Moon and Planets night.
Yep, because the moon.
Because the moon didn't cooperate with weekends this month, so we'll have it'll be a waning gibbous moon, but we'd also have Jupiter and Saturn prominently available. So it'll be a little different, but we'll be there.
And that kind of segues into what we can see. I mean, I know we're not quite to October yet, but what are we going to be looking at in the October skies? And one of the things that struck me when I was kind of doing a little bit of background checking on this is what a really good month October is for meteors. There's a peak of, what do we got here? 6 different meteors that peak at some point in October. So in the 8th, it's the Draconids, which are not a tremendous number of them, but it's such a cool name, you know, the Draconids. It sounds very ominous. So so they peak on the 8th. The Southern Taurs, which are, even though they're advertised as southern, you can actually still see them in the northern hemisphere. So they peak. The Delta Aurigids on the 11th, and I'm never sure what this one is. What Greek letter is? Not according to what I looked at. Is it? Oh, okay. Well, maybe I read the wrong thing on that. But I guess the one that's really sort of the most prominent one is the Orionids. Then this year they're supposed to be especially good. The forecast is something like 24 per hour or something like that. So they should be a pretty good show. You sure about that?
Actually, there may be 2 sets of Gemini.
Yeah.
Yeah.
That's one Gemini.
Yeah.
And there may be another more prominent star off of them.
Yeah, and they're the epsilons. So, and I think that's another one that's a relatively not as many.
The one in December is pretty fantastic. But it's usually so cold that
Yeah. Well, and as I said, the Orionids are supposed to be particularly good this year, but you also have to stay up until like 3 in the morning to actually really see them. So if you're really dedicated, you can take a look at those guys. So these are some of the things that are coming up in October. Planetary wise, it's a good month for planet moon conjunctions. On the 9th, Venus will be close to the moon. On the 14th, Saturn, and on the 15th, Jupiter. So you'll be able to see moon and planets together pretty easily. And if you really want to challenge, Eris, one of the Kuiper Belt objects, will be at opposition. So it should be about as bright as it's going to be in a while. This one will be in the constellation Cetus. It's on October 17th is the best day to see it. You do need a telescope for this one. It's a very, very faint object, but that would be a challenge if anybody's up for wanting to hunt for a relatively faint object.
Doug, if you hit the hide button.
Down the bottom.
Okay. And I guess last but maybe not least, this would actually be a pretty good time to see Mercury as well. I think Mercury and Pluto are, well, Pluto not a, of all the major planets, Mercury is the only one I've never actually seen in person, but its morning peak is on the 24th. Be really low in the sky, be in the east, really low in the sky, like maybe 16 degrees or so above the horizon, but should be visible. It won't look like that, but it will look, but you will be able to see it. So these are some of the things that you'd be able to, and I think you could probably catch Mercury with the naked eye, couldn't you?
You can see it as a star.
As a, yeah, just an, if you look at it magnified, I think it would be a crescent.
It is.
Yeah. So anyway, those are some of the things that coming up for October. And that kind of leads us to what I wanted to sort of talk a little bit about tonight. So yesterday, as we all know, was the equinox, sometime in the mid-afternoon, I think. And whenever the equinox rolls around, it always kind of makes me sort of think about alignments, basically. And alignments always start me thinking about monuments and things from the past and past astronomical data and past astronomical knowledge. So I thought I would talk a little bit about that. And this photo I've always sort of loved. This is the Salk Institute in San Diego, California. And they intentionally designed this so that on the day of the equinox sunset, it lines up with that little long kind of reflecting pool that they built there. And it kind of illustrates the fact that there's, you know, this long interaction in human history between astronomical observations and architecture and art, and in some cases really practical things. So I thought I'd spend a little bit of time talking about that tonight. And so, you know, one of the things that sometimes you don't necessarily think about is why exactly does anybody do astronomy? And you could actually ask a bigger question and say, why does anybody do science? And I think those of us in this room, and probably the ones listening at home, would probably think, well, we do astronomy because it's cool, right? It's interesting. And I think we do science in general because it satisfies a certain kind of intellectual curiosity that we have of trying to understand, you know, how the world works and how things work. And astronomy has become, and not recently by any means, but it's become kind of the biggest of all the big sciences in a lot of ways. You know, it used to be the kind of popular image of the astronomer was sitting in a little drafty dome somewhere on a mountaintop, squinting through things. This obviously not the way it works anymore. And the presentation that we had last week, I think, really drove that point home when Bruce Twarg talked about the Webb Space Telescope and what's the current price tag on that thing? It was somewhere in the order of about $10 billion. Yeah. Which, you know, you think about that in comparison to other things that we've done, and it's a big chunk of money. The entire Apollo program cost $35 billion. Of course, that was late 60s, early 70s dollars, but nevertheless, it kind of shows that this is big science now. And so obviously there's a lot of societal investment in it. And you kind of begin to ask yourself these questions about why are we doing this, really? And I think, again, there's the intellectual curiosity part about it, but it's also, there's a lot of practicality to this. Astronomical knowledge is really practical, and maybe not directly so now, because we have a lot of technology that kind of replace some of the things that astronomical observations were used for, but you can still kind of trace the development of the science through this this practical thing. And I think that's true of science as well, right? I mean, there's the intellectual curiosity and gee whiz, and how does it all work? And then there's also, how do we build better mousetraps, and how do we make vaccines and things of that nature? So there's always been this kind of two parts to this. And again, I'm kind of struck by that when I start thinking about some of these, the fact that there's a lot of really ancient understanding. People have obviously been watching the sky for millennia, if not longer. I don't know what's longer than a millennium, but people have been watching the skies for a long time. This is doesn't show up all that well on the screen, but this is a petroglyph, and this is in White Tank Park in Arizona. And there's a depiction of a constellation, and also what they think is a depiction of a supernova on this. And this was probably something that was observed and recorded. And this is prehistoric, right? This is back before any sort of written history. So obviously people have been paying pretty close attention to what's been going on in the sky for a long time, and making representations of these things. All of this is just a storehouse of knowledge that people have been collecting for probably since the earliest people looked up at the sky and tried to figure out what it is and what's going on up there. But as I said, there's also a lot of practical knowledge. But if you look back in time, and there's a legend that I want to talk about a little later that's always sort of fascinated me. There's an intertwining of the science with mythology and legend, and all these things kind of begin to sort of come together. So all the names of the constellations and things go back into kind of mythology and all. So clearly then, astronomy is a very ancient science. Some would claim it's maybe the oldest science. I don't know if I would necessarily say that. I don't make a case for agriculture being a older science, but regardless of which one came first, it's clearly a science that has a long history in the human race. And here's some examples of that. That thing on the left there is a Babylonian tablet that records Halley's Comet, which wasn't named until what, the 1700s sometime, I think, but has been reoccurring and reappearing for quite a while now. Chinese traditions, the Chinese were very accurate sky mappers. The Maya were observers of this is Maya. This is Egyptian here, and of course the Egyptians, a lot of their monuments have some astronomical alignment and astronomical significance as well. So when you think about the practicality of it, what is exactly that, what is it that ancient people or prehistoric people or pre-technological people might have wanted to know? A lot of what it boils down to is timekeeping. We kind of take it for granted now that we have devices that will measure time very, very accurately, and they measure time very accurately at a lot of different scales, all the way from milliseconds and picoseconds and femtoseconds, all the way up to longer periods of time. But that hasn't always been the case, obviously. And for a very long period of time, the way that time was measured was by looking at the movement of objects in the sky. Over short time periods, we used the movement of the sun was a way of keeping track of time. Over longer periods, over seasonal periods, it was movement of other types of astronomical objects. And that's mainly what I want to kind of talk a little bit about tonight, because like I said, this stuff has always been rather fascinating to me, and I can actually pinpoint the moment or the time or the event that kind of made me interested in the relationship between ancient monuments and ancient knowledge, or in some cases prehistoric, maybe not ancient, but prehistoric knowledge and astronomical alignments. So I'll start off with a story. Anybody ever heard of this guy? Eratosthenes. Many of you probably have. Eratosthenes was a Greek scientist. He actually worked in Egypt, though. He worked in the Library of Alexandria, which was sacked and burned in, I don't know, by Napoleon's troops, I think. But anyway, it was probably at one time the foremost center of knowledge in the ancient world, and this guy was one of the people that worked there. And he before the Common Era figured out the size of the Earth. And I always am just fascinated by this story because it's an amazing accomplishment. essentially what he did was measure the angle of a shadow that was cast. He was working in Egypt, and he noticed that there was a well in the city of Siene, which is now Aswan. It's the modern Aswan. And on a particular day of the year, the bottom of that well was completely illuminated by the sun, which means it's directly overhead, right? So he's in the tropics and he's directly overhead. So on that particular day, he measured the shadow that was cast elsewhere in Alexandria, which is considerable distance away, right? And then just using some relatively simple trigonometry, he was very well versed in the geometry of the day. He was able to figure out what the size of the Earth was and was extremely accurate. He was off by probably somewhere in the order of about 300 kilometers, which when you think about it is pretty remarkable. And all he did was, all he had to work with was, you know, a few sticks, and he basically hired somebody to walk the distance here so he'd know how far it was, which apparently was a profession in those days. You were a measurer, and you had very uniform strides, and you were paid to figure out how far this was. So a pretty remarkable achievement, but it also kind of represents some fairly sophisticated, not just fairly sophisticated math knowledge, but some fairly sophisticated astronomical knowledge as well. You have to understand a little bit about the astronomical relationship of the Earth and the sun, right? You have to know that the Earth's going around the sun, and you have to understand a little bit about that geometry there. So this kind of shows that, you know, astronomical knowledge was certainly nothing unusual in the ancient world. I'm just always just amazed by that story too. But the thing that probably is most gets most of the attention, and perhaps rightly so, is alignments. And by alignments here, what we essentially mean is monuments or objects or something on the landscape, something placed on the landscape in such a way that it refers to some specific or notable date. And again, the reason why this stuff always comes into my mind in the equinox is, you know, on the time around the equinox, I happen to live to the west of where I work, right? So I'm always driving in the morning on the east, and this morning and yesterday morning, the sun's like, you know, directly in my eyes, and my very, very dirty windshield is making it hard for me to navigate. And I'm thinking, you know, why did they line the street with, you know, but it's just been this kind of tendency, and I don't think anybody aligned the streets of Manhattan intentionally to line up with it just turned out that way. But being able to see alignments is a really, really good way to keep track of time on a monthly scale, right? Because it kind of tells you what time of year it is. And if you're a farmer or a person that's kind of depending on some sort of natural cycles, and you can't go get a calendar from the local feed store, you have to rely on another way of measuring time, and that's what a lot of these monuments basically boil down to. So that's one of the things I want to kind of talk here a little bit about. So first of all, just to kind of set the stage here a little bit, you know, these are one of those diagrams that makes my students' eyes glass over a little bit, but yeah, what we're looking at here is kind of the celestial sphere, right? So there's the Earth, there's the plane of the ecliptic right here, which is actually lines up with the Earth's equator, right? So that's the plane in which all objects in the solar system, most objects in the solar system orbit. But it also kind of, if you think then about the movement of the Earth relative to the sun, and it's always easier to think about the sun moving around the Earth rather than what actually happens. But there are these times of the year when the geometric relationship of the Earth to the sun reaches a certain set of sort of inflection points, right? Points where there's a change in a certain kind of behavior. And we call those, of course, the solstices and the equinoxes. The solstices occur in July and December. Typically, the solstices are asynchronous by hemisphere, right? So the summer solstice in the northern hemisphere is the winter solstice in the southern, and vice versa. That's the thing you always can tell people, because there's this persistent belief that seasons are caused by distance of the Earth to the sun. Not the case, right? The Earth is actually closest to the sun during the northern hemisphere in winter, but the asynchrony of the seasons is the big key, which I hope my students remember, because that's in a question on their exam on Monday. But anyway, And that's the period of time when the Earth's rotational axis is either inclined so that the northern hemisphere is receiving the most direct light, or in the case of the winter, the opposite is true. The southern hemisphere is now receiving the most direct light. And of course, that means more energy per unit of area, so warmer, basically. The equinoxes are the time when the Earth's rotational axis is essentially parallel or perpendicular to the sun's rays. So there kind of makes for symmetric receipt of energy of light across the entire globe, right? Sun's overhead at the equator on solar noon and progressively lower in the sky as you gain in latitude. So if you're watching all this from the ground, you see something like this, and this is really where the alignment stuff kind of comes into play. So, you know, if you're this little green person right here and you're looking off towards the east or off towards the west, you would notice that during the course of the year, the sun would begin to rise. The sun would rise within this arc of angle on the Earth's surface, and that arc of angle is called the declination. Such that on the day of the summer solstice, this is northern hemisphere, it's going to be north of east. And then as you kind of proceed through summer and into autumn, it's going to move further and further south. Eventually it's going to rise due east. That's the day of the equinox, and then it's going to go off to the south. And if you think about this position of where the sun is rising and setting on the horizon, that's where this business of alignments kind of comes into play. So here's a nice picture. I'm not sure exactly where this is. Sicily, okay, down there in the left corner. But someone has kind of created a photo montage that kind of illustrates this rather nicely, right? So there'd be the summer solstice, sun's off to the north of off to the north of west. Winter solstice, it's south of west. Equinox due west. You can kind of see the path of the sun that on the days of the equinoxes here, so you can imagine making this arc through the sky and then setting there. And you can also imagine that if you were in this particular scene and you wanted to keep track of all this stuff, what you might want to do is just set up some little sights, basically a little bit like gun sights, right? Where you could sight off on the horizon, and when the sun sets over one of your sights, that's a marker that that day has arrived again, and that's the basis of a lot of these things. So here's again a nice kind of photo montage that sort of illustrates this annual movement of the sunset, or maybe sunrise, I don't know, but regardless. And so that's the sun cycles. The lunar cycle is also something that can be kept track of in a somewhat similar way. The movement of the moon is a little bit more complicated than the movement of the sun because it's orbiting something that's orbiting the sun. But it still kind of shows some regularity in its behavior, and that can be marked as well. So again, there's the kind of geometry of this, and you get these moonset standstills, variations in its rising and setting position that happen on a particular time scale, which again is a way of sort of marking time. So again, these are ways of marking time as much as anything else. All right, so what? Well, again, you can kind of use all this information as a way to kind of create a calendar, basically. And the calendars were often created on the landscape because they were sightings, right? The object was to be able to see where the sun was rising and setting. So if you can kind of imagine that, again, this is a picture that I didn't draw because I have nowhere near this level of artistic talent, but you can kind of see how you might set up a little set of monuments that would point towards some of these moonset and sunset and moonrise and sunrise positions. And then if you monitored this over time, you know, when you went out there every day and looked out at the horizon, you would be able to keep track of the seasons. And again, particularly for agricultural civilizations, where a lot of this stuff kind of came into play when agriculture became kind of the dominant human activity on Earth, this was an absolutely vital way of keeping track of time. And so the alignments then kind of represent this, and they are found in a lot of different forms. There are some that are simply like this. This is just a stone on the horizon that probably was much more closely aligned with the sun at one time. We'll see why that's no longer true. But in some cases, entire buildings or temple complexes or other sorts of monuments were these the alignments were sort of built into those. This is an example of that. This is the Angkor Wat temple complex, which is in Cambodia. And this is just one of the alignments. This is a solstice alignment, but it was just one of it's thought many that were built into this temple complex. So again, this was probably had spiritual or religious significance, but it also certainly had practical significance as well. And of course, probably the most famous monument to show some solar alignments is Stonehenge, which I have never been to. Has anybody ever been there? Yeah. I guess you can't actually get into it now, right? They don't let you go down in amongst the stones. Is that correct?
Believe it or not, there's parking lots full of stuff. Just good, but you can't go on the ground.
Yeah.
I went way back. Yeah, we went right up.
Did you? I know. You see these pictures like this, and you think, oh, it's this monument out on the Salisbury Plain. It's remote and everything. And then you see a larger picture, and there's like a highway that literally runs right next to it. Yeah. But anyway, it's thought to be a temple of it's thought to have a lot of different significances. And I think archaeologists are still sort of figuring out what Stonehenge was really all about. But one thing that's for certain. On Stonehenge? I don't remember that. Really? Yeah, I know they found a lot of remnants of habitation around it. Some of the more recent stuff that I've seen. Anyway, it was also one of the first ones really ever to be seriously studied for alignments, and it actually goes back quite a ways. There were archaeologists in the 19th century that were, and maybe even earlier than that, that had noted that there were astronomical alignments. Probably the tipping point for all this came in the mid 60s, and this is the thing that kind of got me interested in this book here, which I was going to bring my copy of it, and I couldn't find it. It's called Stonehenge Decoded. It's by Gerald Hawkins, who was a professor of astronomy, I believe, at Harvard. And he was one of the first to really kind of intensively study this. And he did it in the mid 60s, and he did it with a computer. And, and back in the mid 60s, doing stuff on a computer was exotic. And so, he wrote this very popular book and claimed that there were, it was even capable of predicting eclipses and things like that. And I think the modern thinking on it is that he kind of overplayed his hand maybe quite a bit, that a lot of the things he thought were there were not. But what was certainly true is that there were some definite alignments to particularly solar and lunar cycles. So, for example, this is the solstice alignment, and you can kind of see this is what the monument would look like if all the stones were still there and all still standing, which apparently they are not. If you looked out through this thing they call the altar stone out to the distance, and I don't know, maybe you could see this when you were there. There are these stones out there called heel stones, and the solstice sunrise would be over them. And so it shows that there's an alignment with an astronomical event. And there's a picture of it right here. You can kind of see this here. From what I understand, clear weather is not very common in this part of England. So it's often the case that people go there to try to see this, and what they end up looking at is clouds. But apparently, if the weather cooperates, you can see this even now. So I don't know, however many years it's been since Stonehenge was constructed, and I guess it was constructed, in stages over time, but it still maintains this ability to show alignments. And here's some of the other alignments that are pretty clear. These ones are fairly well established to actually be the case. Various kinds of sightings, sees winter solstice, summer solstice, the moon rises on the solstices, sunsets, etc. So you can see that there was quite a bit of astronomical calendar knowledge built into this, and it was probably a very practical thing. Again, this was an agricultural society, so they had to know what day it was or when particular times of the year had been reached, and this was really one of the best ways of doing that. Also probably had some significance beyond just practical things. It was probably somehow involved in the spiritual life, perhaps the religious life of it, and in some sense it still is. There are people who continue to gather here on these particular days of the year and observe these things. So it's kind of retained that function a little bit. I know. The Druids, yeah, which I've never really been clear to me whether the Druids actually built or who the Druids even really were. But
My brother and I got arguing about that kind of meat.
I guess they're these sort of neo-Druids now that go out there and they wear white gowns and hang out. So I guess some of these people are probably in that. It's probably pretty cool to watch. I don't know if it'd be worth going and milling with the crowd, but it's probably pretty cool. So Stonehenge is a actually pretty sophisticated piece of architecture too. Quite a lot of work and effort went into building it. But there's a lot of these kind of megalithic alignments in the British Isles and throughout Europe. This is Callanish in Scotland, I believe, and it has astronomical alignments. These are the standing stones of Stennis, and I believe these are in Ireland. But also kind of a similar idea, maybe not quite as large or as as intensively constructed as Stonehenge, but still has the same basic purpose of. So I mentioned that sometimes all these are a little off now, and it actually the reason for that has to do with the fact that the Earth's motion in space is not uniform, basically, or it's not regular. In particular, there's several different types of motions. They actually have a lot of significance for long-term climate, which is how I learned about them back in the day. But they also really play a role in how you perceive astronomical alignments as well. And one of those is called the precession, or the precession of the equinoxes. And the deal here is if you could watch the Earth for a very long period of time as it moves in space, it would look like it wobbles a little bit, kind of like a top, which means that the rotational axis of the Earth is not pointed toward the same spot in the sky all the time, right? It's kind of moving around a little bit. And the number that sticks in my mind for that cycle is about 26,000 years that it takes to maintain a cycle. So right now, the tilt of the Earth on its axis is about 23.45 degrees, but it varies between maybe 22 and 26 or so. So it's all part of this rather complicated motion that the Earth has as it moves through. And one of the things that means is that, as I mentioned, the Earth's rotational axis doesn't necessarily point towards the same spot in the sky, which brings me to one of the coolest things I think I've ever learned. And it has to do with ancient British mythology, which I mentioned earlier. I don't know how much it really has to do with astronomy, but I always thought this was such a neat story. And that's that we've all heard the Arthurian legend, right? The Knights of the Round Table and all that stuff, which is actually a series of literature that goes back quite a long ways, even before some of the more recent depictions of it. But anyway, in the Arthurian legend, King Arthur, was the son of Uther Pendragon. The event that led to the conception of Arthur was I guess, a sexual assault, a rape. But anyway, Uther was Arthur's dad. So Arthur means the bear, and Uther Pendragon means the head of the dragon. Uther Pendragon actually means magnificent head of the dragon, or something like that. And so if you then think about that as an astronomical bit of astronomical knowledge, you can kind of think about it like this, right? So here's this circle right here kind of represents how the rotational axis of the Earth is going to be precessing right? It's going to be moving around in space and pointing to different things. Right about now, it's pointing toward the star Polaris, which is in the constellation of the Bear, right? But at one time, it would have been in Draco, the dragon, and in particular would have been over here by the head of the dragon. So it's thought that maybe this Arthurian legend sort of encapsulates the understanding by which would have required long and careful observation of the sky, that the North Celestial Pole has sort of moved around a little bit. Whether that's true or not, I don't really know. I think I read this in a popular book one time, and the story has always just stuck with me as being incredibly interesting. So I don't know what that's got to do with archaeoastronomy exactly, but it's cool. So anyway, talking about, various parts of the world where this is famous, and North America certainly is not bereft of things of this nature as well. And one of the best places, I think, for seeing archaeoastronomy knowledge applied to the landscape is in the Southwest, in the U.S. Southwest. The Southwestern ancestor in Puebloan, or Anasazi culture, as it's sometimes called, probably had a very sophisticated base of astronomical knowledge. And one of the places you can really see that is this place right here, Chaco Canyon. Anybody ever been there? It is very cool, isn't it? The road to get there is not much fun, but the canyon itself is a very interesting place. And if you ever get a chance to go there, I would really strongly urge it. And I think they actually have the National Park Service does sky shows there, and they have telescopes set up and stuff, because it's very, very dark. Yeah, it's very, very dark. And so it also has this is where it is, basically kind of northern New Mexico. Here's a couple of shots at it. There's the canyon there on the left. It's full, just absolutely full of archaeological sites. You can kind of see some of them here. This was obviously at one time an area of major importance to this culture. But the thing that some of the astronomical stuff, probably the most famous thing is what's come to be called the Sun Dagger. And the Sun Dagger is actually located at the top of a formation called the Fajada Butte. And you can see that over here on the left. And it's up here, actually a little bit off the picture here, on this particular shot. So this is the Fajada Butte. It's closed to the public now. You used to be able to at least hike up to it. When I was growing up, we had a close family friend who was pretty high up in the National Park Service, and he actually got us permission to climb this thing one time. And it's a very, very dicey climb. It's no fun at all to climb. But you get up to the top and you can actually see this Sun Dagger thing. And what it really was just some kind of sheets of rock that have fallen down in a particular way, right? These were not placed there. This is done by chance up here at the top. And at certain times when the light shines through these things, it produces this little kind of dagger-shaped beam of light. So that's marked in behind this thing with a spiral. And it kind of shows you when these dates are. So the solstices, they show up like this. Summer solstice, it kind of cuts down the middle. The equinoxes, they're kind of out on the edge here a little bit. So they kind of operate as a sort of a projected alignment. Unfortunately, this doesn't work anymore. In 1998, probably due to some kind of seismic activity, these rocks shifted a little bit. So the Sun Dagger doesn't work anymore. But when it did work, it kind of looked like that. So it's thought that this was, again, something that was used in this ancient world as a kind of a timekeeping device. Of course, there's now from what I understand, sort of a counter opinion now amongst the archaeological world, that this was kind of done afterwards and more not necessarily to be used, and more just as a demonstration, basically. But anyway, it's kind of a cool alignment. There's one that's a little bit less known, and again, these photos are not real great, but one of the smaller great houses is a place called Wajiji, and it has an astronomical alignment built into it as well. So if you stand in a particular spot and sight off, there's this notch out on the horizon that during the period around the equinox, the sun is sort of in that notch there, so you can kind of keep track of time that way. And it also has a pictograph that is illuminated at that time as well. So this is actually not uncommon in a lot of Anasazi architecture, where they basically use pictographs and shadows and light beams as in the same way that alignments are used. So this is some knowledge from North America, mostly from the American West. This is one that I wish I had seen. My mother used to live in St. George, Utah, and if you've ever been there, there's pictographs and petroglyphs and evidence of ancient stuff everywhere. But I never saw this particular panel. But this particular panel shows a lot of the same constellations that we have now. So this was fairly accurate depiction of the night sky. This is near Ivins, which is a little town sort of to the northeast of St. George. So again, near Taos. Yeah, there's one. Yeah, that's probably not unwise on his part, to be honest with you. There was one that I had seen a couple of times near, it's kind of in the North Phoenix Valley, just north of Apache Junction and Queens Creek. There's a panel that looks a lot like this as well that I've seen a couple of times. But again, it kind of shows, and you can kind of see some astronomical alignments and markers in this as well. So ancient people keeping track of the world. These are ones that are a little closer to home. I'm not sure if there's any of these original ones in Kansas, but there are definitely some in Wyoming, and I believe some on the northern plains as well. And these are referred to as medicine wheels. This was a name given to them, I think, before anybody really understood what they were. But they're kind of the same thing. They're astronomical alignments. They're markers, right? So this is the place where you would have stood, and these were the 4 sites basically, and this marked the location of. And this one is the one in Wyoming. The name is escaping me now. The Bighorn or something like that. Yeah. And this is some of the analysis. One of the first people that did an analysis of this was John Eddy, who was a astronomy professor at University of Colorado, who did a lot of this kind of work back in the 50s and 60s. That he was one of the first to really understand what these things actually were. And there's a lot of them. This is a map showing them some of the locations. And again, not a particularly good map, but you can kind of get an idea where some of these are. That one that we're looking at. So there's also some traditions in the eastern part of what is now the U.S. amongst the so-called mound builder cultures. I guess there was a lot of different peoples that are now referred to as mound builders. The 2 probably most prominent groups were the Hopewell group, and you can kind of see this was the Hopewell area here. So parts of Ohio now, and Illinois, Indiana, Kentucky, I think Tennessee. And then the Mississippian, which was a little bit further to the south and east. So this was kind of a part of the Mississippian. And there are many, many of these sites. And of course, the thing that kind of made this culture noteworthy was not building out of stone like the Anasazi did, but building these massive earthworks, basically. So, and a lot of these earthworks have astronomical alignments associated with them. Probably one of the most famous of the Hopewell group was this Cahokia, which is kind of just outside of St. Louis, just to the east of St. Louis, so just over the river on the Illinois side. And this was a massive settlement at one time. This was probably the largest city in North America until probably sometime in the 1700s. So this was a very, very large settlement. Not much left of it now, because it's a region where there's been a lot of agriculture and a lot of development. It's kind of covered it up. But there is this thing called, yeah, they do. They used to be. I don't know if it still is, but they've closed a lot of these now, because a lot of the old museums were burial grounds, and they basically dug up all these people and kind of left them there. A lot of those I think are closed now, which is probably just as well. But I can remember going to them when I was a kid, you know, and seeing these, and I thought it was fascinating, but I think those are all closed now. But the museums that, the other types of museums, I think are still open. This is one called Monk's Mound. And you can see the top of it here, and this was probably had some sort of ceremonial significance, but there's some alignments built into this. And there's archaeological evidence for what they call the Cahokia wood hinge, which would have been very similar in many ways to the Stonehenge, except made out of wood. Obviously not there anymore because wood rots, but it still kind of shows that this was a civilization that had a fairly sophisticated understanding of the sky. Here's one of the more famous, I believe, Hopewell earthworks. This is called the Serpent Mound or the Great Serpent Mound, and it's really, really huge. I actually have seen this, and it's really interesting. You can't see the whole thing when you're there because it's long and kind of curved. Looks like a big snake, but it also has some alignments built into it. Some of the major features of the snake point to particularly significant places on the horizon. So again, a pretty good example of, you know, ancient understanding of the sky that was pretty significant. All right, so just to wrap this up then a little bit, I want to kind of show you something because this, I just happened to notice this on my bookshelf at home when I was getting ready for all this, and it kind of struck me a little bit. This is a book, I don't know if you can see it, but it's called Archaeology, Anthropology, and Interstellar Communication, which is a pretty cool name for a book. This is a book that was actually published by NASA. I don't know if you know it or not, but NASA gives books away for free. So I sent off for a big box of books from NASA several years back, and this was one of them. And one of the things that kind of struck me about this was that the reason why they were thinking about archaeologists and anthropologists for interstellar communication is these are people that have been trying to essentially figure out what people meant in the past using very, very sparse clues in a lot of cases. So the idea is that maybe that we can kind of transfer that knowledge. So eventually one of these days, maybe sort of when we finally do make some sort of contact with people who are not us, that might provide at least some analog for kind of how to proceed and perhaps how to understand communications that are not that are when we can't directly communicate with whoever's involved in this. So they make a point in this. This is an edited volume, and I haven't read the whole thing, but they make a point that this may be a way to kind of think about how to interpret the information we may receive from elsewhere. So I don't know about that. I feel all like that's all a little outside of my my bailiwick, but it's really an interesting idea to think about that, you know, maybe by understanding how to communicate with the past, we can also maybe understand how to communicate with others as well. And with that, I will stop.